Okay, here goes example 2 on section 8.2. We have this cone and we want to find the volume of it. And again, we're going to use calculus and try to break it down into simple pieces that we can find the volume of easily. So if we look here, I have the cone here, and what we're going to do is to slice it into little bitty thin discs. So this disc here, check it out here. So this is the disc, and it has a width here. All right, that we're going to call delta H, and for this one, let's say the radius is R naught. Okay, so to find the volume of one of these, so the volume of the disk is very simple. Pi, the area, times the width. So pi R naught squared times delta H. Okay? And then if we do that everywhere for every height H and we add them all up, we'll get the volume. So the problem now is that we've got the radius and we've got the height, so we need to get the radius in terms of the height. So again here, if we slice that thing straight down the middle, we would see that we have the cross section would be this rectangle here. This rectangle with a width of 10 and a height of 5, and we're right in here, and we see that width. So that was R naught, or R, they call it R out there, I call it R naught. So the whole width would be 2 R naught. And this height here would be some H naught. And so we can get, again, let's see, what are we going to do? 2 R naught over 10. 2 R naught over 10 is going to equal to this height here. What's that going to be? 5 minus H naught over the total height. 5. Okay. So this is going to multiply both sides by 10. Well, 2 tenths becomes 1/5, so we just get the R naught equals 5 minus H naught. Okay. So now going back up here into our volume here, we have the volume of the disk equals pi R naught squared, which is 5 minus H naught squared delta H. Okay, now if we created one of these disks for every H naught and then added them all up, we're going to get a great approximation of the volume of this cone. And then we well, let's do a couple here. So the volume of the cone okay, we would do pi times 5 minus H naught squared delta H, and that would give us one of those little disks. And we would do another disk, pi times 5 minus H1 squared delta H, and we would continue doing those. So we did a bunch of them. Pi times 5 minus Hn delta H. And we see here again we have a Riemann sum. So if we take the limit as n goes to infinity here, we would get that the volume is going to be this integral. And as we're integrating with respect to h is running from what? 0 to 5. 5, oops, no, pi can go here. Pi times 5 minus h squared dh. Okay? And now, so we get pi I believe we can all integrate this pretty easily. 0 to 5. Well, we get 25 minus 10h plus h squared dh. And this is going to be pi times 25h minus what, 5h squared plus h cubed over 3, running from 0 to 5. And let's see, so the zeros are going to all be gone, and let me pull up my calculator and knock this thing out. So we get 25 times 5 minus what, 5 times h squared is going to be what, 5 cubed. 5 cubed plus 5 cubed over 3. Oops. Divided by, right? Let me go back, delete. 5 cubed divided by 3. Enter. And then we're going to multiply times pi. We're getting 130.889. Let's see again. 130.899. So let's go with 130.9. So this is about 130.9. And again, this is area, so it'd be square feet, square inches, whatever you're working in. Let's check the text answer here. They left it as an exact answer. 125 divided by 3 times pi. 125 divided by 3. Enter. Second. Oops. Times second pi. Okay, good. So it's just checking our answer there. Okay, and that's going to conclude this video on example 2 of section 8.2. Again, the big key here is being able to use similar triangles, and then knowing that the volume of something is simply going to be the area times the volume of a nice little disk is going to be the power squared times the width of the disk times the delta H. Alright, thank you.